Hi everyone, today we are going to study Kruskal's algorithm to find the shortest spanning tree. In the Kruskal's algorithm, we start with an edge with the minimum cost. So we start with the minimum cost and you can clearly see that the minimum cost is between vertex A and B, which is 5. So we draw our vertex A to B. We draw the edge between vertex A to B, which has minimum cost 5. So 5 is the minimum cost among all the costs. After 5, we see that the next minimum cost is 6 between vertices C and D. So we can draw this. Now, after 6, the next minimum cost is between vertex B and D, which is 8. So we will draw this also. After 8, the next minimum cost is between vertex B and C. But if I draw an edge between vertex B and C, it will cause a cycle. So I will not do that, right? Any edge that is causing a cycle will not be drawn even if the cost is minimum. So this minimum cost will be ignored because an edge between vertex B and C causes a cycle. Now the next minimum cost is 13, which is between vertex A and C. So again, if I draw an edge between vertex A and C, a cycle will be formed, and I cannot do that because I'm finding a minimum cost spanning tree, and a spanning tree does not have cycle. So if I draw an edge between vertex A and C, then a cycle will be formed. So I will ignore this also. Now, after this, the next two available edges are with the minimum cost 15 and 20. So obviously out of 15 and 20, the minimum cost is 15, which is between vertex A and E. So that means I will draw an edge from vertex A to vertex E with a minimum cost 15. So this gives me my minimum cost spanning tree with a minimum cost of 34. So this is how you find out the minimum cost spanning, the minimum spanning tree using Kruskal's algorithm. So this is how we have found minimum spanning tree using Kruskal's algorithm having minimum cost 34.